Okay, well, so let's go ahead and get started. I don't have a lot planned for today. I was going to just remind people about the test, see if anybody had a question on it, do a little bit of a review maybe, just my idea on what you ought to be looking at. So if you didn't see the announcement, or if you're joining this after I post this online, the test is going to be conducted online through MyLeo Online for everybody, both my 574 and my 520 students. So it'll be like a time test. There'll be a 2-hour time limit. I'll just open it up Thursday, kind of after my normal face-to-face meeting here. So sometime Thursday after about 9:30 it should be open. So anytime on Thursday or Friday, you can go ahead and start it. So it will be that you will need to go into MyLeo Online and start it there. You'll be given the questions through the normal quiz test mechanism. But I'm expecting you to have your Python Jupyter Notebook environment set up and running. And in fact, there will be a link for Notebook. There's not much in it, but basically before you start the test, you'll want to go ahead and download the IPython Notebook. So you'll get the questions online. There'll be 3 of them, I think. I can talk a little bit more about those. But I'm expecting you to basically write Python code in the IPython Notebook, and then there will be a folder for you to submit it. So basically, you'll have a 2-hour time limit, but you will need to upload it to the notebook submission folder for the test 1. Okay, so so I'm expecting that if I'll give you maybe 5, maybe at most 10 minutes of a bit of a leeway to get your notebook saved and uploaded here. But so yeah, we're not using GitHub or anything. You will have to make certain that you can know where your notebook is and that you can successfully attach it or upload it to the submission folder for the test 1. So just be aware of that before you start the exam. Make certain that you know where this is and also know where the notebook is that you're going to be doing the exam in, and that you can navigate there and upload it in a timely manner once you're done with the questions. Okay, so I've never really had a good format for these tests. They're not meant to be particularly difficult. It's basically the same kind of stuff that we've done for the 3 assignments we've had so far, and the stuff that we've talked about in our lecture notebooks. But hopefully most people will find it relatively simple. It's meant to be able to be done relatively easily within that 2-hour time limit. Okay, so yeah, there's 3 questions. There should be 3 questions if I remember right. So there'll probably be like a question that'll be just a more general Python, so write a Python function kind of thing. So kind of like the first assignment, we had a question writing a recursive Python function. So you'll be given something. Although I think that on this question, so if you want to start talking about reviewing for some stuff, it will be a Python function that's expecting you to do some NumPy kinds of things. So it'll be a little bit of practice on writing a Python function, but also like taking a NumPy array or a matrix and doing some operations on it, and then maybe returning the result or something like that. So that's typically what that first question is. So yeah, probably my basic recommendation is to go back and look at the assignments. So go back and look at the 3 assignments we've done so far. Those will give you ideas on stuff that you might want to review, that you might want to kind of self-assess of whether you need to think a little bit more, read a little bit more about certain topics and things. So that'd be one of the questions. The other 2 questions are going to be basically you'll be given like a data set that's meant for a regression. So the second question is probably here's like a data set, or here's some generated data set. Do a linear regression on it. and then do some of the typical things that we've done in this class. So, evaluate how good the fit is, maybe visualize it, so plot the resulting model, the resulting regression line, extract the parameters, maybe, that kind of stuff, right? So that would be kind of simple. And then the third one will also be similar, given a data set that's meant to be a classification problem, probably a binary classification task, because also on that one you might be asked to visualize the decision boundary, for example. So remember, we've done that a couple times, but make certain you can do that by hand. So if you have a simple binary classification and it's only two features, you ought to be able to take the parameters of your fitted classification, like logistic regression. I'll probably ask you to just use logistic regression. So take the parameters and then visualize the decision boundary. So visualize the line that results, that separates, that's the boundary between the two classes that you have on there. So, and also, for example, so you might have to do, I can't remember exactly, but the kinds of stuff that we've done for classification problems. So to evaluate it, like maybe display the confusion matrix, maybe even determine the precision and recall, maybe plot an ROC curve. So those kinds of things might be asked to be done on the classification problem. Those are typical things that you should that you might want to do to evaluate the model that results from trying to fit a set of data that's a classification. So the linear regression might, so one of our whole assignments was on polynomial regression, so it might be, instead of just a straightforward linear regression, fit a polynomial regression, so it could be either way. So you might want to review that as well. But there should only be 3 questions, if I remember right, so there'll be kind of one more of a general Python NumPy question, and then one for like a linear regression, possibly a polynomial linear regression, and then one for a classification, which you should probably use logistic regression for that. All right. So the notebook should already be visible now. I just made it visible this morning. So let me know if you can't see that, but you can go ahead and get that. And like I was saying, I would, I am expecting that you're going to be using the same environment that we use for the class assignment. So probably the easiest thing to do would be to just use one of the repositories. Like for example, your most recent assignment 3, just take the notebook and put it into the notebooks folder and reopen. So do the normal thing. So run Docker and reopen it in the running container. That way, you'll be ensured that you're using the correct versions of the libraries and stuff that I'll be testing things with. Although, again, for this test, there's probably nothing that's going to be that would cause potentially problems with using some features that might have changed, So I'm saying it probably won't be a real big issue, but the safest thing would be to use the same environment that we've set up for the 3 assignments that we've done so far. But as long as you're using like Python 3.12 and kind of relatively recent versions, you should be okay, I would think. So. But do just check that out before you start the test. Make certain that you can get the notebook and you can open up. There's really nothing in there. It's just a placeholder. It does import kind of the basic things. So this notebook, imports things to do like a linear regression, logistic regression, and a couple of other things that I gave you here. It might not have everything. So if I didn't mention it on there, I should probably check my instructions as well. But if I didn't mention it in the description in that notebook there, if you need to, and you very well might need to add in some additional imports. So not everything might be imported there that you might need in order to do the test, right? Because I don't think I imported things for to do like ROC curves or precision recall and maybe some other stuff like that might not be in there. So don't be surprised by that. There's just some basic things in there, I think, to like import the basic linear and logistic regression models from scikit-learn and a few other things. So you probably need to add some additional imports in there when you're answering the questions for the test. So. And it mostly just imports NumPy and Matplotlib in the usual way, that kind of stuff. But I would encourage you to get a chance to download that and just have it set up before you start the test. So. All right. I don't know. Is there any questions on that? For anybody watching this after the fact, I don't know if I made it clear enough on here. I would like everybody to get it done before Friday. I don't really want people to be going into, we are up to spring break. We are up to the halfway point basically this week for our spring semester. Hopefully everybody's aware of that. And I would like everybody to, take a little bit of a break. And but yeah, if you really need a little bit of a different time frame than that, let me know. I can maybe fiddle that a little bit, although I'd rather not go into the weekend. People should let me know about that, like today, if you have a request for something outside that that window, Thursday, Friday, then I'm going to try to get everybody to work on the test. So. Okay. Oh, yeah. I mean, yeah. Actually, I do have the notebook up here, so I probably should just show that. So like I said, it doesn't really. There's really nothing in there except for some imports. So the NumPy, Matplotlib, pandas, and it does import the linear regression, logistic regression. There's a few things that you will need for some of the questions in there that's imported, but this might not have everything. So yeah, it does import confusion matrix and accuracy score, but there might be additional things that you'll need to import on there. So, but I'm expecting you basically to do your work inside of the notebook, save it, and then you'll need to know where your notebook is so that you can upload. I usually have one or two people that are a bit confused, so they don't exactly kind of know where their stuff lives on their file system. But anyway, you should try and be clear about that kind of before you start the test. So which notebook you're actually editing in. So I always get somebody who uploads the wrong notebook. The one they were thinking that they were working in wasn't the actual one they were doing the work in. So, but yeah, so try and think about that ahead of time before you start your test. So, because unlike for our assignments, you won't be able to have it kind of done for you in VS Code where you just add the file to a commit and get it pushed up there. You want to make certain you get the right file uploaded and attached to the submission folder for the test one, so that so I can see what you actually end up working on during the test. So. I didn't set this up ahead of time, but oh shoot. Well, So I'll just say a little bit more. Like I said, it might be a relatively short day today because I don't have a whole lot to go over. I've been the last thing I was going to mention was probably. So this week is meant to be a bit of a review, so go back. We have covered quite a bit, so we didn't necessarily assume that you knew Python programming, but you had to come up relatively quickly up to speed on the basics of writing code in Python, and not only that, though, using some of the libraries that we make extensive use of. So those are basically like NumPy, Matplotlib, and Pandas, right? So there is kind of a question that's on Python and NumPy. So it'd be a good idea to review those kinds of stuff from the first 2 or 3 weeks that we worked on. And you've had a lot of practice. Hopefully, you've had a lot of practice on the assignments on using NumPy. Using Matplotlib, at least for the basics, to plot and visualize some things. I guess kind of as a hint for anybody watching this, I would, for like the first question, I probably would go back, think about this notebook a little bit. So the first question is usually about doing some vectorized operations on NumPy. So, you might want to go back and review some of that stuff. So especially like the advanced indexing and shaping and some things like that, and the idea of vectorized computations using NumPy arrays. Hopefully everybody's kind of familiar at this point, understands what I'm talking about here when we talk about like a vectorized computation. So when you use like NumPy, it is a kind of a different way of thinking of writing programs. So there's different kinds of styles, different ways of writing programs. There's straightforward procedural programming, where you usually break things up into functions, and then you call the functions and get a result back from them. There's object-oriented. We touched a little bit on that as well in this. The first week we had a little notebook and discussion on how you can write object-oriented designs or programs in Python. But yeah, doing things in kind of a vectorized way is also sort of a different way of thinking about programs. So it's very muchly about if you're familiar with linear algebra, that's a good kind of a thing to understand sort of why things are done the way they're done when you use NumPy. So, but the basic idea, is that we have lots of operations that we can do using the NumPy library and using vectorized operations where we treat an array, even a multi-dimensional array, as kind of a singular object. So we do operations over all of the elements of an array. Right? So that's the basics. Like you have a multi-dimensional array, we can just have a simple expression like that. And so normally when we do procedural programming or object-oriented programming, these kinds of expressions have to be done on scalar values, on something that's only holding a single value. And if you need to do it over a collection of values, you have to write loops in order to apply like a multiplication or some other operation to all the values inside of your collection. So when you're doing vectorized, kind of this way of doing this that kind of originated with MATLAB was one of the first, I think, that I used to use MATLAB a long time ago. So it was one of the environments that pioneered this way of kind of doing things in a vectorized, thinking of things as matrices and applying linear algebra sorts of operations. So yeah, there are, I think the questions, like on the first one, it'll be kind of similar to some of the stuff that we talk about, doing some vectorized operations on some things. So yeah, it will be incorrect to fall back to trying to use some loops or something like that. So you really do need to be doing using the NumPy vectorized operations rather than trying to do nested loops or something to do whatever's asked for on that first question. And there might be a little bit about some of the more advanced kinds of stuff, like fancy indexing and Boolean slicing like we had to do on the first assignment, where that was useful for our question about where we made the nice fancy fractal figure on that one. So we might do a little bit of that on the first question for the test here. Like, for example, maybe building a Boolean index and using that to only operate on some selected portion of a multidimensional array or some operations like that. And there will be some questions to do some plotting things, but mostly it'll be basic plots of the same. So we haven't done a whole lot of kind of advanced things on our assignments so far of visualizing things. So the stuff that you should have learned so far, just how to create a simple plot on an XY axis to visualize like a learning curve, or to visualize the point of the data set, and maybe also visualize the fitted line or the decision boundary. Probably have to do a little bit of that for the tests. And also, I mean, probably only incidentally, in fact, you might not have to use pandas on the test now that I'm thinking about it. So you will have to use some data sets, but they might be given to you, or they might be generated for you. So the data sets that you're likely to use for the test questions will be, in the same format that you should be familiar with. So it will be, you can think of it as a table where the columns are features and the rows are samples, and one of the columns is like a regression label or a class, a category, so a categorical label that you use to build either a regression model or a binary classification on. So with that said, I've been thinking about the lecture notebooks. I probably would recommend, maybe reviewing the stuff that we talked about on the Unit 4, on the binary classification. So the test question about binary classification will probably be pretty much doing the same kinds of stuff that we talked about here, and also in the second assignment where we did a binary classification. I don't think I asked you to do anything with stats model like we did on the second assignment, so it'll be just use scikit-learn to fit like a logistic regression, and then potentially measure the performance on some in the similar ways that we discussed. So confusion matrices, maybe ask you to do recall and precision, and then maybe even the plotting those against one another, or plotting like ROC curve kind of thing. Yeah, and then besides that, so for the second question, it will be about linear regression, maybe polynomial linear regression. So, reviewing our most recent assignments and reviewing the lecture notebooks on linear regression and then polynomial regression. I can't remember, but yeah, we could ask you also to apply some regularizations, and you might have to do a linear regression or even a logistic regression, but regularize it a little bit, like with the lasso or um, like we did on the most recent assignment. So all that stuff would be a good idea to look back over, review a bit. But it probably, as a recommendation, you probably want to concentrate on the basics, right? So this test, again, I don't mean it to be, get into a lot of the real detailed stuff. It is meant to be done within a time limit kind of thing. So if anything, if you've only started reviewing like right now, you definitely want to start with the basics of all these. So like the first notebooks on each unit is usually kind of like the thing. So 4.1 on binary classification, the 5.1 on linear regression, maybe the 6.1 on the following regression, and the learning curves would be good places to concentrate on. If you have a bit of limit on your time on some stuff that you want to think about and review as you're preparing for the test this week. But yeah, I don't think I'm giving away too much. So, most of the stuff, hopefully, we have practiced it in assignments. We've seen examples of it, so that would usually what the questions are, where you do a linear regression or logistic regression, and you fit a linear regression, and then you evaluate it in some of the ways that we've shown. So, calculate its performance, calculate its cost on maybe the test. So you might have to split into test and training data. Can't remember if I asked you to do that or not, but then evaluate it, its error, so like root mean squared error. Maybe show its parameters, then ultimately maybe visualize the resulting fit that you had with the data, those kinds of things for the linear regression part of the test. So. Okay. What else? So I'm kind of, I think that was mostly what I wanted to cover today. We still have quite a bit of time, but so this is mostly just to give some hints on what you might want to do to review. Make certain everybody knows what the format is going to be. So I hope everybody does well on the test. It's the time, the time limit is the only thing that's a little bit different. It should be pretty similar to the assignment stuff that you've worked on, although simplified, right? So there is you don't have to write code in a separate Python file, and so we don't set it up with tests or anything like that. It's more straightforward that you just have to write. So you'll only be doing work in the IPython notebook for the 3 test questions you give. Each of the questions are, 3 questions is a little bit unfair. Each of them there's 3 parts. Each one is kind of multi-part. So in each case, so especially for the last 2, it's usually here's some sort of data set, so fit a model to it, and then evaluate it in some of the ways that we've done for our assignments and then our lecture notebooks. So evaluate how well the fit was, show the parameters, visualize the resulting fit. Those will be the basic things that you'll get for the last 2 questions. All right. Okay. Did you guys want to bring up or ask anything about the test? If not, yeah, I'm probably just going to go ahead and in for today. And I'm not really planning on doing anything on Thursday either, although I will be in here So, because I got a class at 9:30, so if you did have other questions next week, feel free to come by. But otherwise, we'll go ahead and end there for today. I'll let you guys, review on this. So just prepare for this, get it done at the end of the week, and then take a bit of a break, and we'll come back after the break and get into. After the break, we're kind of, so the first half of the course we've done sort of the basics, right? So learning a bit about linear and logistic regression gives sort of a foundation of kind of the idea of how these sorts of things work for supervised learning. So after the break, we'll get into the details of some of the more complex, the better performing models. Okay, so linear and logistic regression are usually used more like for baseline models, just to see, so usually they're not expected to be the best kind of model. It's just we should be able to build things that would perform better than a basic linear regression or logistic regression. So we'll look at some of the more powerful models, support vector machines and ensembles and things like that for most of the second half of the course. So. All right. Yep, that's it for today. I'll just let you guys go then, unless you want to ask anything. So. I think I'll go ahead and stop the recording here too, and we'll post that so that anybody online can see this information too. So.